Howdy. When I was a kid, I really liked playing with Rubik's Cubes. My uncle would give me a hard time about it. He always said this thing about how he would solve it by taking the stickers off and gluing them back on. It really bothered me. I think following the rules of the Rubik's Cube was important to me. I also genuinely enjoyed the process of moving the pieces by turning the sides. So just getting the stickers in the right places seemed meaningless. As often happens to kids like that, I grew up to be a mathematician. The mathematical objects I study are called groups. In a group, anything you can do, you can undo. A Rubik's Cube is an example. If you turn a side, you can always turn it back. Adding numbers is also an example. If I add a number, I can undo that by adding its negative. Mathematicians in my field are trying to classify all of the groups, like how in biology they're trying to classify all the species. This is a huge mathematical project, not something one person could do in a dissertation. One tool we have in this project is we have a way to tell if two different looking groups are actually the same. My friends and I turned that tool into this computer program. You have a necklace of colored beads that corresponds to a group. On the left are some buttons you can press that change the necklace in certain special ways. What's special is the changed necklace, which you see on the right, has to correspond to the same group as the original necklace. So if I have an entirely new necklace and I want to know if it corresponds to one of the groups we've already classified, I can type it into my program, and then I just have to check if I can press the buttons to turn it into one of the groups in my good old Groupodex. So there's an existing computer algorithm to decide if you can do it or not. I found a way to speed it up, though. So the algorithm that exists has to read the necklace over and over and over again. I found for every group in the Groupodex a pattern you can look for in the new necklace, where if you see it anywhere in the necklace, even as just a part of the necklace, it means you can't find a match. These patterns that I found are based on work from 90 years ago by a mathematician named Henry Whitehead. I don't think he could have anticipated how I'm using his work. When he wrote about these necklaces, computers barely existed. It was decades before Erno Rubik invented my favorite toy. I don't know if I can predict how people will use my work in the future, except I know I'll use it. My friends and I are turning this Groupodex idea into a real online encyclopedia of groups. And at my advisor's suggestion, I'm turning this puzzle game into an iPhone game, so kids who like brightly colored math toys can experience PhD level math. Thanks, y'all.